Don't worry, you don't need to be an engineer to pass the electronics questions. If you can handle a flashlight battery and a few simple formulas, you're already most of the way there. So some of the biggest things that you're going to have to know. Ohm's law. That's one of the big ones. If you struggle with electronics or any sort of understanding of that sort of thing, you definitely want to focus in on Ohm's law and understanding it. So if I can't explain it to you well enough, ask ChatGPT, because it can explain it in 9 different ways that'll probably stick better than this. But I'm going to do my best. So voltage, current, and resistance. We got a formula. V equals current times resistance. So voltage equals current times resistance. So the electronic pressure voltage, it's like the push, right? Current is the flow of electricity. So that's, how much flow is actually going through the pipe. And resistance is like adding some sort of nozzle onto the end of that big pipe. So, it's going to back up the pressure, increase, with the increase in resistance comes an increase in voltage, an increase in current, which then, could equal a higher voltage. So on the exam, often just plug numbers into this formula. It's just going to try to throw you by having a question about Ohm's law and make you use the formula. So really make sure you understand Ohm's law. So power, how you find the output power in watts, you would multiply the voltage by the load. So 12 volt battery times 2 amp load equals 24 watts. Light bulb brighter with higher power, that type of thing. So the power equals how much work is being done. So, that 24 watts, that's how much work is being done. So the 12 volt battery, 2 amp load, 24 watts. That's how much power we're getting out of that. So what is the power if a 12 volt circuit draws 2 amps? 24 watts. So decibels, an audio measurement. Decibels are a logarithmic scale, but the exam level is easy. Okay, so plus 3 decibels equals double the power. Plus 10 decibels is 10 times the power. You don't need to calculate the logs. Just remember these key values. So 3 decibels means double the power. So if you have a 3 dB antenna, effectively you could be doubling your power. 10 dB antenna, amplifying your power by 10 times. So this is the output power on the other side of the antenna. So this is not measuring output at the radio. You do not need to calculate the logs. Just remember these key values. So grounding and fuses. So radio, fuse, battery. You always need a fuse. So always use fuses in DC power lines. Prevents a fire if any short occurs, protects your equipment if any sort of short occurs. So proper grounding protects against lightning, reduces noise, and keeps you safe. So like I was saying in a previous video, when you have an antenna on your house, especially on a tower, we need lightning protection and proper grounding. If your tower ever got struck by lightning, it's going to destroy everything in its path to get to the ground, whether that's your radio, whether that's you yourself, if you're using your radio, whether that's the tower itself. You need to have proper grounding, proper lightning arrest, and that's going to keep you safe. So on the exam, you can expect questions like, why use a fuse or why ground your tower? Those are pretty straightforward questions, and it's if you have a slight electronics knowledge, those things are very it's not rocket science. So along with those lightning arresters and grounding, we need RF safety from the energy that is emitted from the radio. So radios emit RF energy, and too much of it can be unsafe. So you need to limit your exposure. Keep antennas away from people and use proper power levels. If your neighbor's lights are flashing up and going crazy, you're probably using too much power. So Canada follows Safety Code 6 guidelines. Some of the exam questions are simple. They want you to know, don't stand next to the antenna while transmitting 100 watts. It's as simple as that. Don't grab the antenna while you're transmitting, things like that. It's pretty straightforward stuff. RF energy affects the body in different ways. Your eyeballs are actually the biggest RF sponge, so you want to keep those high-powered radios away from your face. A 10-watt handheld, don't put that next to your eyes. It's probably not actually 10 watts, but don't put it next to your head. Use a hand mic, because that's a lot of power to have right out next to your eyes and your brain and all that stuff, right? So putting it all together, a couple sample questions. What is the current in a 12-volt circuit with a 6-ohm resistor? So the formula, we already talked about that. So 12 divided by 6 equals 2 amps. What happens if a 20-amp circuit is fused at 5 amps? Pop. What is the effect of doubling the transmitter power? 3 dB, right? Doubling 3 dB, 10 dB is 10 times the power. 3 dB is doubling the power. The questions that are on the exam, it's pattern recognition. Plug in the formula where it's required, or recall the safety facts, right? Like the fuse is going to blow if your if your tower gets hit by lightning. If you're not properly fused, what's going to happen? That sort of thing. It's pretty straightforward stuff. So that's electronics and safety, a little bit of Ohm's law, some power math, and common sense safety. Once you recognize these power questions, these patterns, these questions are straightforward. So next up, we're going to cover frequency and modulation, the real magic that gets your signal into the air, gets your signal propagated. And please, if you haven't already, follow, please subscribe, like this video, and comment if you've ever blown a fuse in your setup. Have you melted something? Let me know down below.